Welcome to this explainer. Look, if you're an industrial procurement professional, you already know we're in the middle of a massive shift in manufacturing right now. Procuring a CNC lathe in 2026? Yeah, it's no longer just a standard equipment purchase. We're talking about a massive, data-driven, long-term capital investment that literally makes or breaks your facility's competitive edge. You're dealing with high-precision, multi-axis capabilities, and integrated automation, the whole shebang. So your procurement strategy needs a completely new roadmap.
But before we get into the heavy technical weeds, I want to pose a quick question to you. What do you think is the single most expensive mistake you can make in industrial sourcing right now? Just take a quick second and guess.
It's focusing solely on the sticker price. Seriously. It's a tough pill to swallow, but experienced buyers know that the initial price tag, it's just the very tip of the sourcing iceberg. It's all that hidden stuff underneath the water that will absolutely sink your operations budget. Okay, let's dive into this. Here's our strategic roadmap for today. First, the TCO reality check. Then, defining technical requirements. Next, the global supplier map, followed by the 2026 procurement workflow, and finally, tailoring your sourcing strategy. Starting right off with Section 1, the TCO reality check, or looking beneath the sticker price. So here's our first real paradigm shift. To get to true procurement efficiency, you got to completely rewire how you evaluate cost. It is absolutely crucial to shift your focus to the total cost of ownership over a 5 to 10 year lifespan. Think of this TCO iceberg as having 4 solid pillars. First up, acquisition costs. That's your base unit, your specialized tooling, initial shipping. But then you hit operational expenses. And in 2026, with industrial power costs doing what they're doing, energy efficiency ratings are non-negotiable. Then comes maintenance. Do you actually have local service techs available? Are you stuck buying insanely expensive proprietary spare parts, or can you use universal ones? And lastly, training. You've got to upskill your operators for very specific control systems. By rigorously calculating these 4 pillars, your procurement team can easily justify dropping more cash up front on a premium machine. Why? Because it practically guarantees significantly lower maintenance headaches and a way higher resale value down the line.
Moving on to Section 2, defining technical requirements, matching specs to production needs.
I honestly cannot emphasize this enough. Before you even think about writing an RFQ, your requirements have to be crystal clear. Overspeccing a machine, you're just torching capital. Underspeccing, you're going to create costly production bottlenecks. So let's apply the key technical filters you absolutely must be using. First, capacity limitations. We're talking swing over bed to define your max rotation diameter and center distance for that long shaft stability. Second is spindle RPM. This is absolutely critical if you're cutting small parts or non-ferrous metals like aluminum and you need that flawless surface finish. Third up is spindle torque, which is essential for heavy-duty cutting of stuff like hardened steel or titanium. And finally, live tooling. This gives you mill turn capabilities for one-hit machining. And let me tell you, investing in a one-hit machining center is a total game changer. It can dramatically reduce your floor space and labor costs by literally replacing the need for extra milling machines.
Now this brilliantly illustrates how the diverse landscape of CNC lathes matches directly to your specific application and sourcing complexity. Take a vertical lathe, or VTL for example. Those beasts are built for heavy, large-diameter parts, mainly targeted at bulk buyers in the energy sector, so they come with a high sourcing complexity. Contrast that with a flatbed CNC lathe, which has low sourcing complexity and is perfect for small buyers or educational setups needing heavy-duty, simple geometry. The whole point here is to match the exact machine type directly to your specific production needs.
All right, let's wade into a massive debate in the industry: FANUC versus Siemens controllers. On one side, FANUC is basically the industry standard for general turning. It's legendary for extreme reliability and the fact that you can find spare parts globally without breaking a sweat. On the flip side, Siemens gives you this incredibly intuitive graphical interface and totally superior performance when you're dealing with complex milling and multi-axis tasks. Your choice here shouldn't just be about which brand you like better. It absolutely must link directly to your existing operator skill sets and your part complexity. Remember that training TCO we talked about earlier? This is exactly how you manage it.
Which brings us to Section 3, the global supplier map. Basically how geography dictates build philosophy.
There's a very clear price to precision progression across the globe, and understanding these geographic clusters is going to save you a ton of time narrowing down your supplier list. Step 1 is mainland China, the undisputed largest producer in the world. The clusters here offer unmatched lead times and highly competitive pricing, and honestly, their top-tier brands are getting incredibly competitive in the multi-axis segments. Step 2 is Taiwan. This is what we call the value-precision sweet spot. You're getting robust iron casting and highly reliable electronics right at a nice mid-range price point. And then step 3 brings us to Japan and Germany. This is it, the absolute gold standard for precision and longevity. These machines are built specifically to survive 24/7, high-intensity production environments. Figuring out exactly where your needs fall on this map is literally the foundation of your sourcing strategy.
All right, Section 4, the 2026 procurement workflow, prioritizing verification and validation. Look, when you're dealing with an investment that easily exceeds 50 grand, you absolutely need a non-negotiable, structured workflow to protect yourself from bait and switch tactics. Here are 3 bulletproof steps you need to implement. Step 1, technical RFQ alignment. Please don't just ask for a generic CNC lathe. You have to specify material hardness, exact tolerance levels, and your required controller brand. Step 2, the factory audit. Check for those ISO 9001 certifications and demand total subcomponent transparency. Ask them point blank, where are the critical components coming from? Are they actually using trusted SKF bearings or high-wind ball screws? And step 3, performance testing. Always request a test cut video, or honestly, even better, a high-def virtual live demo. Send them a sample of your actual material and physically verify the cycle time and the finished dimensions.
Now, speaking of logistics, let's talk timelines. 30 to 60 days. That's the typical lead time you can expect for standard, high-volume machine models.
But, and this is a big but, that reality shifts completely if you need customizations. Want increased spindle bores, specialized turrets, integration with robotic cells? You just pushed your delivery out by months. You're suddenly looking at 4 to 6 months of lead time, plus an extra 4 to 6 weeks just to deal with sea freight and customs clearance. So you've got to be incredibly proactive with your timeline planning here.
Let's hit Section 5, tailoring your sourcing strategy, aligning your approach with your business model.
Every single buyer is different, right? So you have to adapt your approach based on your exact scale and operational needs. For example, if you're a small buyer, you should really be hunting for all-in-one packages, stuff that includes startup tooling and solid English tech support. E-commerce sellers, you probably want to focus on Swiss-type micropart specialists so you can crank out high-volume, low-cost microcomponents. Brand owners or OEMs, you need to be negotiating long-term exclusivity, custom exterior branding, and priority service. And for the bulk buyers out there, your absolute North Star is factory automation. You need to ensure your machines can seamlessly integrate with robotic arm loaders and centralized monitoring software. The point is, a small shop's needs are universally different from a massive facility integrating robotics.
All of this strategic planning leads us to what we call procurement realism. This is the data-driven practice of balancing technical machine performance with that total cost of ownership over a multi-year lifespan. And a massive piece of this realism puzzle is how you manage warranties. If you're importing machinery, you should actively be negotiating a critical spares kit to ship right alongside the machine. You also need to ensure your contract strictly guarantees remote video support and express shipping for replacement components. You've got to minimize that downtime at all costs.
So, if you take nothing else away from this, remember this crucial point. The cheapest machine often becomes the most expensive over time due to maintenance and precision loss. That right there, that is exactly why we obsess over calculating TCO, demanding subcomponent transparency, and running rigorous factory audits.
Which brings us full circle, right back to the iceberg. I want to leave you with a provocative thought, something to really challenge your current mindset before you go. Ask yourself, is your current RFQ process evaluating the entire sourcing iceberg, or are you still just looking at the sticker price? It might just be time to completely overhaul your approach for your next major equipment purchase. Thanks for hanging out with me on this explainer, and hey, happy sourcing!